So, what are the requirements for a knowledge representation language? A knowledge representation language should have the following characteristics. 1, it should have representational adequacy. It should be good enough to represent the problem that I am thinking of representing. So, it must be expressive enough to cover all the ideas that needs to be represented. It must have clear syntax and semantics. How to write a particular proposition in that language and what is the meaning associated with that proposition, it needs to be very clear. Third, it must have what is called inferential adequacy. One needs to have the ability to derive new knowledge from the given set of statements in the knowledge representation. That is, one would love to infer, or what we say the KR language should have inferential adequacy. It must be that when I am deriving new knowledge from existing statements in the knowledge representation, it should do it efficiently, and that is what is called inferential efficiency. And finally, the knowledge representation that I have should have some naturalness, in the sense that a human being should be able to make out what is being represented by actually looking at it and trying to get the essence of the thing. We will come back to this when we will be talking of what we mean by a KR language being natural. Now, in practice, no one language is perfect, and different languages are suitable for different problems. Let us first try to understand what we mean by representational adequacy. Consider the following facts here. The first statement says, Mohan believes no one likes cricket. The second statement says, most children believe in Santa. And the third statement says, Mr. Kumar will have to finish his assignment before he can start working on his project. Now, I could have used a language like C and represent these statements as strings. Can I represent all these as strings? Maybe yes. But then the question is, if I want to manipulate and draw conclusions, I would have a lot of a problem. So, how do we represent things formally in a way that can be manipulated in a computer program? That is what is answered by the idea of representational adequacy. Some notations or languages only allow you to represent certain things. That is fine, but if it represents, it should be manipulable. Now, concepts like time, belief, uncertainty, all are hard to represent. In fact, in this course we will look at how to represent uncertainty, and also we will talk of how to represent beliefs and time and some point of our discussion. A representation need to have well defined syntax and semantics. So, knowledge representation languages should have precise syntax and semantics. One must know exactly what an expression means in terms of objects in the real world. This is because one needs to understand that when I am doing knowledge representation and reasoning, I am actually mapping the real world to representation of facts in the computer, and then this is where inferences are being drawn and new conclusions are being gathered. Now, after the new conclusions are being gathered, it is important that I can map back to the real world. If I do not have clear semantics on what is the meaning of each of the symbols that I am using here, this mapping back to the real world will be either ambiguous or would not be possible at all. So, one needs to have precise syntax and semantics for a knowledge representation language. This is something that one needs to understand very, very clearly. This is precisely because I bring from the real world into the computer the facts of the world in terms of a representation that I myself define and use. And that representation must therefore have precise meaning associated to it, every symbol that I am using. So, we should exactly know what an expression means in terms of objects in the real world. Now, we will take a moment to understand what we mean by syntax of a KR language. In any knowledge representation, there would be a group of symbols arranged in some way. But then what would be considered properly formed and what would not be considered properly formed is defined by the syntax of that knowledge representation language. So, in English, for example, if I take two strings now, the first string, the cat my mother loves, actually is a well formed phrase. Whereas, if you take the next one, the my loves mother cat is not a well formed phrase, and therefore, the first passes the syntax of English, the second does not. The syntax consists of a set of symbols used by the language and a set of rules according to which the symbol can be combined to form proper sentences. So, we need to understand that for a knowledge representation language, we must have a precise syntax defined. The semantics, on the other hand, specifies what the well formed expressions of a knowledge representation language are supposed to mean. The semantics actually is a mapping between the symbols, combination of symbols, proposition of languages and concepts of the world to which they refer. So, a proposition in a knowledge representation language does not mean anything on its own. The semantics, that is the meaning of the proposition, must be defined by the language author through something called the interpretation. So, that is very important, that I have a precise syntax and a precise semantics. Now, let us focus on the next requirement of a knowledge representation language, which is inferential adequacy. Representing knowledge would be really not interesting unless you can use it to make inferences. We should be able to draw new conclusion from existing facts. If I say a statement like, if it is raining, John never goes out, and I say it is raining today, then one can immediately draw a conclusion that John is not going to go out today. The ability to derive this new information that John is not going out today based on two bits of information that I have specified. One, if it is raining, John never goes out. Two, it is raining today. That ability that I can get a new inference drawn is called inferential adequacy. So, we should come up with solutions to complex problem using the represented knowledge, and that can only happen if the knowledge has enough inferential adequacy. Inferential adequacy in a sense refers to how easy it is to draw inferences using the represented knowledge. Representing everything as natural language strings would really have good representational adequacy and naturalness, but very poor inferential adequacy. Now, let us take a minute to understand what we mean by this. This is because natural language strings, if I use to represent a certain problem, I can represent anything and everything using natural language strings. But given a group of natural language strings, it would be very difficult for a computational mechanism to draw a new group of natural language strings. Now, this is something we must take note, that this is not that this is impossible, but then we are talking of the level of difficulty. The difficulty on working with just natural language strings would be far more than the difficulty of working with a group of symbols that I would use to refer to those natural language strings. And therefore, if I am doing something in natural language strings, I would have very good representational adequacy, but I would have very poor inferential adequacy. Next requirement is about inferential efficiency. I should be able to make, in principle, complex deductions given the knowledge represented in a sophisticated language. Now, the more complex the possible deductions are, the less efficient will be the reasoner. But then I must have the ability to make complex deductions. So, we need representation and inference systems which are sufficient for the task without being hopelessly inefficient. Let us now look back on what we had introduced in one of the characteristics of a KR language, that is the naturalness. If our representation schema is quite intuitive and natural for the human reader, it would help both the representation and the reasoning. So, could represent the fact that my car is red using the notation something like X, Y, Z, Z, Y, bang, zing, where X, Y, Z, Z, Y could refer to redness, zing refers to my car, and bang here is used in some way to assign properties. But then for a human reader, the statement here would really be not comprehensible. Contrast this with the following. Let us write something like car SMH and color red, where car X can refer to the owner X and color X can refer to the X color. Now, the second group of statements that I have written is more understandable or natural in some way than the first one. A knowledge representation language needs to be something along the second line than along the first, which is very incomprehensible. The desired features of a knowledge representation language, therefore, would be at the epistemological level, we need to have clarity and expressiveness. At the logical level, one needs to have elegant syntax and semantics. It needs to be decidable or tractable. It needs to be sound and complete in terms of its inference. And in terms of implementation, we need to have space and time efficiency, and it must be extensible. This is where we would see that for knowledge representation and reasoning, formal logic is the first choice. Why is logic the first choice for a knowledge representation language? Is precisely for the reason that logic is a formal language with precisely defined syntax and semantics, and it supports sound inference. The language is independent of domain of application. Now, there exists different logics which allows one to represent different kinds of things with more or less efficient inference, like we have propositional logic, predicate logic, temporal logic, modal logic, description logic, so on and so forth. Representing some things in logic may not be very natural, but then inferences would be very good. At times inferences may not be efficient as well. Under such circumstances, more specialized languages may be better. But here in this course, we will focus on formal logic for knowledge representation and reasoning. So, what are the advantages of logic for knowledge representation? Like all declarative languages, logic is compact, task independent, modular, reusable, flexible and maintainable. Logic has formal, well defined semantics, and logic is expressive. Historically, logic is the first knowledge representation language. First order logic has been the knowledge representation language for artificial intelligence from around late 50s. Around 65, we had seen Robinson come up with resolution, which meant real hope for universally applicable proof method. We will look at resolution as part of our discussion on first order logic. Around 70s, a number of rivals to logic emerged, like semantic networks, rules, frames. However, they had unclear semantics and inference, and around 75 with logic programming, we did decrease expressivity, but there was a huge increase in efficiency. Logic regained its place in AI as a knowledge representation language. Around 1980s, there was non-monotonic reasoning introduced, which could deal with common sense knowledge. So, as part of introduction to knowledge representation and reasoning, we will start with propositional logic. We will see propositional logic has drawbacks. So, we will consider the more general first order predicate calculus. Now, first order logic or first order predicate calculus is symbolized reasoning, in which each sentence is broken into a subject and a predicate. The predicate modifies or defines the properties of the subject. First order logic provides a well defined language for us to express knowledge, and this is what we will take up for discussion in our next class. Thank you.